Hello, physics. Today we're going to be taking notes on velocity versus time graphs. Yay, whoopee, woohoo, woohoo. All right, let's go. So, here is a position versus time graph. We are very familiar with these. As you can tell, we have a positive constant slope here, which means that our position is changing at a constant rate. All right. Now, if our slope is constant, that means that we have a constant velocity. Okay. So there's some things that we can infer from this information given to us in this graph, even without any numbers. All right. So we can say that the slope of this line is positive. All right. We can look at it and see that it is increasing in position with every second. We can also say that the slope is positive and constant. We know that it's constant because it's a straight line the entire time. So that's real easy. Now, we also know that on a position versus time graph, slope represents velocity. Okay? So what we can infer from this information here is that if slope represents velocity and our slope is positive and constant, then that must mean that our velocity is positive and constant. So let's imagine that we're going to make a graph of velocity versus time. All right? Now, the times are going to be matched up in between these two graphs. So as you can see, I've drawn a dotted line from the position versus time graph all the way down to the velocity versus time graph, because these things are going to share the same amount of time because they're graphing the same motion. So looking at this, I need to graph a velocity that is positive and constant. All right? So what I'm going to do in order to show that is I'm going to draw a line that is on the positive side of the velocity, which is going to be here, and constant. A constant velocity means a velocity that is not changing. All right? Now, if you can imagine that there was a number here, let's say that this velocity was 5 meters per second, I can see that at every instant of time here, I'll draw that, every instant of time, there's 1 instant, 2, 3, 4, and so on, and so on, and so on. Each of these instances, I have a velocity of 5, 5, 5, 5. It does not change for the entire motion. Okay? So we can pretty easily tell just right away from that graph that a positive constant slope is going to yield a velocity time graph that looks like this. All right? So let's look at an example with more pieces. Let's look at this example here. Okay? So in this example, I've got 3 sections of motion. I've got this first section, second section, and third section. All right? Again, we don't have any numbers here, but we can infer some things about these graphs. All right? So we need to be asking ourselves the following things. Is it positive or negative or 0? So we got positive, negative, or 0. And is it constant? All right? Positive, negative, 0, or is it constant? So let's look at section 1 here. So section 1, that slope is positive, okay, because it's moving in the positive direction. And yes, it's constant. All right? Now in section 2 here, if you can imagine this is a position versus time graph, let me draw a dotted line here. As you can see in this section of my graph, my position does not change. My position is the same for that entire section of motion. So if my position doesn't change, the slope of that line is 0. And guess what? It's 0 the entire time, so it's constantly 0. Now here, we also have a positive slope because it's increasing in position. And that's also a constant slope because it's a straight line. So then this is the information that we're going to use to make our velocity versus time graph. All right? So we come down here, and here in section 1, I've got a positive constant velocity. So we're just going to draw a straight line there to represent my positive constant velocity. Then I have a velocity of 0, all right? So this line right here is going to find itself placed right on the x-axis there, all right? Because that right there represents a velocity of 0. And then finally, at the end, we also have a positive constant velocity. But as you can see, the line in section 1 is steeper than the line in section 3. Therefore, we can say that the velocity of section 1 is greater than the velocity of section 3. So when we draw our line to represent the velocity at section 3, what we've got to do is we need to draw that line a little bit underneath the velocity of section 1. So as you can see here, now what I've got is this velocity, we'll call this velocity 3, is smaller than the velocity of section 1. Now, what do we do if we've got some areas that are decreasing? All right, so in this section, I've got 4 sections of my graph, and section 3 here happens to be decreasing in position. So let's look at this. Again, we're going to ask ourselves the same questions. Is it positive, negative, or 0? And is it constant? I guess 2 questions. And, we'll add in another one here. Is it a high velocity, a low velocity? So we'll go the magnitude. Remember, magnitude just simply means value, the number associated with it. All right? So let's take a look. Here in section 1, we've got a positive slope because it's increasing in position. It is constant. And that's a pretty steep slope, so we can say that it's, we can imagine that it's going to be a big number, all right? In section 2, I have a flat line. Flat line means I have a slope of 0. And just to clarify here, guys, these questions I'm asking about here are all related to the slope of the line. And even though it's 0, it is constantly 0, so that's constant. And the magnitude of this is 0. The value of that slope is 0. Here, I've got a slope that's going to be negative. It's constantly negative because it's constantly going down. And that magnitude, it's not as high as section 1, so we can say it's somewhere in the middle. And then at 4, we've got a positive slope that's constant. And we can say that that magnitude's the lowest out of all of these because you can see here that that is the shallowest slope that's on this page. All right? So that information we can use to now make our velocity versus time graph. So first off, I've got a slope that is, I have a velocity that is positive, constant, and large. All right? So positive, constant, and large, that's going to give me probably a velocity that's somewhere up here. Now again, a 0 velocity that is constantly 0, I'm just going to draw that line, and I'm going to place that line at the 0 mark of our velocity, so right there. Then I've got a negative constant velocity. All right, so we're going to have to change our graph here a little bit. I'm going to move my time axis up here, all right? Then I'm going to move my 0 back here. So now we've got this side is my positive velocity, this is my negative velocity. So if I have a negative velocity, it's going to go maybe right here. And then at the very end, I've got a positive and constant velocity, but it's small, so something like that. So now I've got my 4 distinct sections of motion. 1, 2, 3, 4. Positive, high, constant velocity, 0 velocity, negative, constant, and kind of fast velocity, and then positive, constant, low velocity. And that's all we're going to need to do to graph that.